All right, so in this video, I'm going to do something slightly different than the last video. The last video, I started out with 2 points and I found the perpendicular bisector. In this video, I'll start out with 2 points. Let's do -3 comma 5 and it doesn't really matter, 2 comma -3. And what I'm going to do is I'm going to find how the shortest distance from a third point, let's say 3 comma 4, the shortest distance from a third point to the line that connects the original 2 points. So let me say that again. The original 2 points here, you can connect them with a line, right? And I want to find what is the shortest route from my new point to that line. And if you just sort of visualize, there's a lot of different routes. I could go in many different ways. There's an infinite number of paths that I could walk from this point C to the line that connects A and B. But only one of those paths is the shortest. And it turns out that that path is perpendicular. What I can't assume is that it's the perpendicular bisector of AB. Because depending on where my point C is, if I scoot this point C around a little bit, like if I made it 3 comma 7, well, that's not going to hit at a perpendicular bisector. It's going to hit at a perpendicular line, but I need to figure out exactly where that line intersects. I can't just assume it's the bisector. So we're going to go through this video here, similar to the last one, but a little bit different because I'm not assuming bisector. So first thing I'm going to do is find the slope of AB, doing rise over run. So the second y value minus the first y value, the second x value minus the first x value. So that gives me -8 over 5. Now I know that the perpendicular slope is opposite and reciprocal. Negative becomes positive, rise becomes run, and vice versa. So now I know that the line here has a slope of 5 over 8. In fact, if I type in y equals 5 over 8x, 5 over 8x, you can see that that is perpendicular. It's just not hitting the point that I want it to hit. The point I want it to hit is 3 comma 7. So I use my point slope form. Y minus 7 equals 5 over 8 times x minus 3. Remember, point slope form, y minus the y value, slope, times x minus the x value. And I'm just going to mention again that you can remember this formula because it looks a lot like rise over run. Remember, here's rise over run. If you just grab the denominator and slide it over here, you got your point slope form, just as a reminder. So I'm going to type in now our point slope form of our perpendicular line. Y minus 7 equals 5 over 8 times x minus 3. So great. I didn't draw it super well, but we have now the uh, the picture. But the tricky thing is, I actually am curious in what is this point right here? Where does it actually intersect with my original line? And anytime you're asked to find an intersection, you're going to try to think of it like a system of equations. Think about solving it with substitution or solving it with elimination. So I've already got one equation, y minus 7 equals 5 over 8 x minus 3. I'm going to find another equation using AB slope and using either one of the points, either A or B. It doesn't matter, just pick your favorite one. I'm going to use B. So my other equation is y minus -3. Remember, you subtract the y value. So if you're subtracting a negative y value, you're going to write down plus in your equation. And that means whenever you see an equation that has y plus a number, you need to interpret that as a negative y coordinate. Equals slope times x minus the x value. What I'm going to do is type that in and then clear the screen so I don't lose, so we can kind of clean up a little bit. So here, oops, almost x minus 2. So here we are. Let's clear the screen. We have our original points. I can get rid of this purple line. That was just to show the direction. We have these original points right here. And the beauty of Desmos is, man, we can just click on that and look at that crazy answer right there. But what if you're asked to do it by hand? What you can do is dig deep. Remember your system of equations skills. We're going to take these two equations and we're going to do substitution on them. So the first equation can be rewritten like this. If I add 7 to both sides, I get 5 over 8 x minus 3 plus 7. And the second equation can be rewritten like this. If you subtract, 3? If you subtract 3 from both sides, you get this. And both these equations are now equal to the letter y. So I can grab this and set it equal to this. They're both equal to the letter y, so I can set them equal to each other. All right, the numbers are going to get a little nasty because of the fractions, but the process is what's important. So don't get hung up on what the numbers are. I'll just use a calculator, get my decimals, go through it. So here's what we're working on. 5/8 x minus 3 plus 7, negative 8/5 x minus 2 minus 3. Let's distribute on both of those. 5/8. I think I'll go to decimals at this point, just because I think a lot of you are more comfortable with decimals. So 5/8 is 0.625. So I've got 0.625x, and then 5/8 times 3 is 1.875. So I've got negative 1.875 plus 7. Then we got 8/5 is 1.6. So negative 1.6x. 8/5 times 2 is 3.2. And that's going to be a positive number. And then the minus 3 that was hanging out at the end of the line there. Now you can combine your like terms. Combine these two dudes. Combine those two dudes. So we have 0.625x plus whatever negative 1.875 plus 7 is. 5.125. And over here, we have negative 1.6x. 3.2 minus 3 is 0.2. Then we're going to get our x's on one side. So I'll add 1.6x. And that gives me 2.225x plus 5.125 equals 0.2. And then we're going to get our numbers on the other side. Subtract 5.125. And I get 2.225x equals negative 4.925, and then divide by 2.225. So x is negative 2.213, blah, blah, blah. Once you have the x value, you can plug it back in to either one of your original equations to find the y value. I'll just use the equation on the left. So the y value is 5/8 times x, so negative 2.213 minus 3 plus 7. You can type that all in as one line. Calculator can look like that. Hit answer, and I get a y value of approximately 3.742. So let's see how I did. Checking by clicking on the intersection point. We got it right on the dot. Literally right on the dot. Okay, so thanks for watching. Please comment and ask questions if there's anything there. And make sure you're able to do perpendicular slopes, point slope form equations, and refreshing your system of equation skills. I know you've done it before, but it takes some practice to get it back. All right, thanks for watching.